We are going to go over some more practice questions on work, power and energy, and also laws of motion. A roller coaster shown below starts at the top of its track at point A with a speed of 12 meters per second. If it reaches point B traveling at 16 meters per second, what is the vertical distance h between A and B? Assume friction is negligible and ignore the kinetic energy of the wheels. So the path we have is, let me make it more like that. This is point A, there is point B. So something has to move from this point and comes to this point. So what we want to determine is the height difference between the point A and the point B. At this point A, it is traveling at 12 meters per second, and then at the point B, 16 meters per second. So let's take it like this. So if we consider point A, what kind of energy does the particle possess at point A? So it has got kinetic energy because it is having a velocity. It also has a potential energy, that is mgh. So by the time it reaches point B, now I'm taking the elevation not from the bottom of the hill. So my point of reference is this line which I've drawn here. And that is where the particle is, or the roller coaster is. So at that point we're going to take that. What is the height of B from this line? Well, that is B itself, so it's 0. That will be, if we take the height from the very bottom, it can be a certain value, but with reference to this very point, this point is 0 because I am taking height as h. So there will be no potential energy at that point because we're going to take it that that's the minimum it will be at. So there will just be kinetic energy. And so kinetic energy here is given by half mv squared plus potential energy, which is mgh, and that will be equal to kinetic energy, which is half mv squared. Energy is always conserved, so this is going to be half the mass of the particle. We are not interested in the mass, we don't need to know it, will cancel out through the velocity at the point A, that is 12, we get to square that, and then plus g, which is 9.8 times the height which we want, and that will be equal to half the velocity at B, which is 16, we get to square that. 12 squared is 144, and 144 divided by 2, that is 72, and that will be equal to 16 squared, which is 256, divided by 2, which is 128. I'll take 72 the other side, so 9.8 h is going to be 128 minus 72, which is going to give us 56, and we divide both sides by 9.8. So that is going to give us 5.7 meters. So that is the height h which is being given there. An inclined plane making an angle of 25 degrees with the horizontal has a frictionless pulley at its top. A 30 kg block on the plane is connected. So this is a 30 kg block connected to a freely hanging 20 kg block by means of a light rope passing over the pulley. The coefficient of friction between A and the incline. So A is this mass which is here on the incline. So there's a coefficient of friction there, mu k, which is 0.1. So calculate the distance the 20 kg block will fall in 2 seconds starting from rest. So we want to find how much will it this fall in a time of 2 seconds. So the first thing we're going to do is we need to find the acceleration at which this will be dropping. So starting with this mass, since this mass is dropping, then the direction of motion is going to be like this. So even this one is going to be put like that. So the forces going first in the forward direction, we've got the tension that will be pulling there's going to be FG. By reason of this being on an incline, there's a force pulling it down. But since there's also friction, there's also kinetic friction which will be pulling also down. So the net force on what is on the incline is going to be tension going in the direction of motion, kinetic friction is going in the opposite direction of motion, and then Fg is also going in the opposite direction to the direction of motion. So be mass times acceleration, that will be equal to tension minus kinetic friction is given by coefficient of kinetic friction times normal force, and then minus Fg. Fg is given by mg sine theta. This is one equation you need always to know. And this is mass times acceleration, that will be equal to tension minus mu k. Normal force is on an incline is given by mg cos theta, and that will be mg sine theta. So we can now substitute the mass, that is 30 kg. So that will be 30 multiplied by A is equal to T minus mu K, that is 0.1, times the mass, which is 30, times G, which is 9.8, cos theta, the angle of the incline, that is 25, then minus mass again 30, 9.8, and then sine 25. 30A is going to be equal to T minus, so we've got 0.1 multiplied by 30 and then multiplied by 9.8. We have got cos 25, and then okay, that is going to give us 26.645. We've got minus 30 multiplied by 9.8 multiplied by sin 25, 124.25. So that is going to give us 30A being equal to tension minus, so we'll get to subtract negative 26.645 minus 124.25. And that will give us 150.89. 895. Let me make T the subject of the formula. So T is going to be equal to, I'll take this term the other side. So that is going to be 30A plus 150.895. So be our first equation. Now let's look at this mass which is here. So the net force acting on it is given by, so that one is moving in the y. The force putting it in the direction of motion, that is mg, the weight. And then tension is the one going in opposite direction, that is given by mass times acceleration, which is equal to mg minus t. So the mass there is 20 multiplied by the acceleration, that will be equal to 20 multiplied by 9.8 minus tension. Again, I'll take tension the other side, it becomes positive, and that will be equal to 20 multiplied by 9.8, which is 196. And then I'll take this term the other side, so it becomes negative 20A. So this is tension is equal to, this is also tension is equal to, so we can equate these two terms since they are equal. So 30A is going to, 30A plus 150.895 is going to be equal to 196 minus 20A. So taking this term the other side, 30A plus 20A, that is going to give us 50A, and that will be equal to 196, taking this term the other side. So 196 minus 150.895, that is going to give us 45.105. So the acceleration is going to be equal to 45.105 divided by 50, 0.902 meters per second squared. What is the question asking us about? Calculate the distance the 20 kg block will fall in 2 seconds from rest. So what we want to calculate is the distance it will fall. We know that 2as is equal to v squared minus u squared. But we don't know the final velocity at which it will be when it gets to fall in that time. So We are going to look for another equation. H is equal to ut plus half at squared. So this will be h is equal to the initial speed. They've told that when it falls from rest, so this is going to be 0, and then plus half. The acceleration here is 0.902. It will not be acceleration due to gravity because it is not falling freely, and then multiply by the time for 2 seconds, so that will be 2 squared. So therefore the height is going to be half multiplied by 0.92 multiplied by 2 squared, which is a 4. That is going to give us 1.8 meters. That is how far it will fall when it gets to fall for 2 seconds. Thank you so much for being present. Enjoy the day.